start. Over the last several years, there has been a significant change in the organization and architecture structure at Klarna. The new setup, the new organization supports independent team that have end-to-end responsibility and that can design, develop, and deploy their code separately and independently. In this talk, I'm going to try to take a look back and summarize the personal learnings and what worked and what didn't work for us while transitioning to this new organization. Same as Felipe, I would like to set the expectations straight. This talk is based on personal observations and by no means aims at providing the single right way you should do things. Instead, I hope to plant ideas and topics for discussions. And if you disagree, that's perfectly fine. Just ask questions at the end of the talk, or we can grab a beer at the end and just talk about it. And this is not a technical talk. So with that said, let's go. As I'm an infrastructure person to a large extent, today I'll focus mostly not on the code structure, but rather on the processes and practices that tie together the system and the team. So the three main things I would like to discuss are continuous deployment, automation, and structuring of microservices. Okay, without further ado, let's go to the first one, continuous deployment. I would like to take a look at it in perspective, starting with continuous integration to continuous delivery and then to continuous deployment. The idea, I will introduce them each of them. So the idea of continuous integration is quite not super new. I would say it's quite popular thanks to the agile methodology for quite a while already. I don't think I really need to introduce it to you that much. Continuous delivery is slightly newer. The main idea of continuous delivery is to be able to perform a release at any moment in time. In terms of DevOps, this means being able to deploy current master or current main branch to production at any given time. The deployment doesn't have to happen at every change, though. This is an important thing to note. Continuous deployment takes this idea one step further and requires that actually every change to the main branch is deployed to production after the tests are successful. So to kind of summarize this transition, this aims at reducing the feedback loop further and further. So this is the main goal of this transition. And I would like to say that in the teams that I've been part of, we tried continuous deployment with, I would say, it's huge success. So the main motivation when we started with a new platform at Klarna was as simple as, let's just try it. What can possibly go wrong, right? And actually, it worked surprisingly well for us. So what benefits we saw are more frequent deploys means smaller changes per deploy means reduced risk. Release happens at the moment of most awareness, where people that just worked on the change have all the context fresh in their head and can jump and fix the problems as soon as possible if they occur. And last but not least, it's increased happiness. It's just the sheer reward of you seeing your baby code work in production right away after you wrote it and released it, and people using it. This is just a great feeling. Well, so a bit to the other side. I've heard some people not so enthusiastic about this whole idea of continuous deployment. Feels a bit scary when you just start with it. And some of the concerns I've heard are, we need to test things first. Well, okay, that's a reasonable concern, but what about your test pipeline? Do you not trust it enough? Maybe it would be a nice time to spend to improve your test pipeline to the point where you are comfortable with just merging and releasing stuff without having someone to manually log in and verify, oh, does this button look great? Yeah, okay, it still looks fine. For us, it actually forced us to improve our pipeline to the point where we were confident that if we just push and the tests pass, everything is going to be fine. Well, of course, you have some sort of issues along the way, but you figure them out and improve. It's a feedback loop. Another concern that people mention is that we need to wait for a good time to deploy the change. It's also kind of like, why would you have this motivation? It's usually a business raising this as an issue. They are a bit worried that, well, we shouldn't really release from 8 to 5. It's kind of scary, and like on Monday, it's also the really high traffic. So maybe we should postpone the release to some later date. So I would say this is not a really good. It's not a really good motivation. You should try to combine both, decrease the risk and increase the frequency of releases. And there exist technical techniques to address this, such as feature toggles, where you enable certain functionality based on the configurations. Then you can trigger it when you want, and if something doesn't go well, you can quickly disable this functionality. Canary deployments, where you deploy the functionality to a limited set of machines to just kind of try the water and see how it goes. If something goes not that great, you also can withdraw. And such recent things as the scientist library. Have anyone heard about it? Yeah. So there exists such a library for Ruby, and there are ports to all sorts of languages where you can basically have two code flows. You have the current one that you know is working fine, but you've implemented the new version, and you want to try how it works. But you don't necessarily want to jump on it right away. You want to also take it easy. So this library allows you to trigger both flows, with the main flow actually returning the result and you using that result, but the other one being run in some sort of a dry run mode, where you can see, okay, it failed in this input, and it wouldn't actually break your system, but you would get a report. So check it out. It exists for all sorts of languages nowadays. So it really doesn't stop you from going with continuous deployment this concern either. So, okay, let's now make you a bit even less comfortable. What about this idea? So consider the following idea. I was thinking about inserting this slide with from the matrix. What if I told you? So every developer of the microservice works directly on the master branch, directly, without any branching. And every push with successful test run is deployed directly to production. The first reaction to this I usually see is this. Yeah, I like emojis. And indeed, it may sound scary. In fact, when I was presenting it at an external conference last year, at Triada Business Day, Enterprise Day, as one of the possible continuous delivery approaches, a lot of people were kind of scared and came by after the talk to discuss it and said, like, no, like, in my organization, this wouldn't fly at all, completely. I was a bit interested, and we talked about it, and turns out that their main concern was not technical at all. It's not because, oh, my language doesn't support it, or like we have this old IDE, whatnot, pipelines and stuff. It was actually cultural implications. And the hardest change needed to go with the continuous deployment, the true continuous deployment, is the cultural one. You have to address the issues in your organization. What people complained about was people just commit and run. You know that term? When somebody is like working hard all day and then, oh, it's 5 p.m. Shit, push, and just go home. And that's it. I mean, nothing bad about that, but you need some sort of like check how things are and take responsibility and so on. And another one, which is even scarier, is they just didn't trust their other team members to do good quality work. Like, oh, if Joe pushes, like, no, shit, like, I cannot just let this happen. I need to check first. He always does some crap. So, and like, if we look at it, this is not related to continuous deployments at all, or to the workflows. This is organizational problems, and they need to be addressed. And you can go with whatever deployment workflow you want if you have some basic prerequisites for a well-functioning team, such as knowledge sharing, good communication, shared responsibility, and trust. If you have those, you can go with whatever deployment pipeline you want. Nothing will stop you. I would like to point out one more thing, that even if you don't implement, just evaluating this mainline-based workflow is a good test for your architecture and the team, the organization. It will force you to like think, oh, yeah, this part is not automated. Maybe we should take a look at it. And well, is this step really needed? Do we need to do it every time manually? Yeah. So even if you are wary of this approach, I really encourage you to try it out and see how it goes for you. It's like, I think the best motivation was, let's try it. What can possibly go wrong? Well, a lot of things, but you will try it. So, and if you're still skeptical, I would like to point out, I'll refer to the authority and say that the browser that most of you are most likely using, Chrome, is actually developed using the only master workflow. People work directly on master, and they do continuous deployments. So if Google does it, you know, what can possibly go wrong again? Okay, well, off to the next topic, automation. Well, yeah, start with low-risk, frequent tasks. Automate those first. Great. But tell me something more interesting, something not obvious. Captain Obvious, I hear you say. All right, I would like to question some things here as well. What about this? Automate all the things, the meme goes, right? You have seen it, everyone. In our profession, this question kind of doesn't pop up, and everyone is very enthusiastic about automating everything. Like what I can, like, if I spend 10 minutes on that every day, I should definitely automate it. So I would like to challenge it a little bit. In a sense, I'm not against automation, but I would like to promote being conscious about it and the implications for your organization. Think about this. So, ironic, isn't it? It's the automation that is great. It works 99.99 something % of the time. It works perfectly, and people almost never need to do anything with it. And then when it breaks once a year or something, no, everyone is like, okay, so how does it work? Yeah, well, I haven't touched it since ages. Like, what do we do? So it leads to this interesting irony of automation. It is the most successful automated systems with rare need for manual intervention, which may need the greatest investment in operator training. It's kind of self-defying to some extent, isn't it? So what I can say is that automation that nobody can maintain becomes dangerous. And a developer building a complex automation that nobody in the team can maintain on their own and then leaving the company becomes a super huge risk for the organization and for the team, and can actually stop any deliveries from happening from that team for weeks or months even. And Don't tell me this never happened at Klarna. Don't tell me. So it's really important to look at automation not separately, not in its own, but in relation to its intended users and maintainers. And this is really important to keep in mind, not only for developers, but for engineering managers. So engineering managers, we can probably take the questions at the end of the talk, if you're okay with that. So it introduces unnecessary risks for your organization that could be easily avoided by knowledge sharing. And I would like to stress this in the sense of DevOps specifically, because with this vertical team structure and end-to-end responsibility, the team has to care about their deployment pipeline and the often infrastructure. And in itself, it may be quite complex. And sometimes developers are not like very eager to work on the infrastructure. I just checked today the job posting on the Klarna's careers site. It has nothing about working on infrastructure for the software engineer position. Has pipelines, delivery pipelines, that's good, but it doesn't have anything related to the infrastructure work. And we kind of have to do that nowadays with this end-to-end responsible teams. So this shift to the DevOps is quite recent, and not everyone is so eager because people may not be familiar with the tools and techniques, and it feels a bit, kind of sensitive. Oh, I can do that. Kind of like, give me my cozy Java IDE. I will work there and deliver a lot of code, but that infrastructure, let this one guy handle it. So I would say that you should really avoid a dedicated infrastructure role in your product team. I'm not saying that you should avoid a platform team or a specific infrastructure team. That's great to have those. But if you have a product team with end-to-end responsibility, you should really not have that one guy. Oh, yeah, deployment, talk to that guy. He's at home today, but tomorrow maybe he will help you. So don't have that. I've been in this position myself. So that's why I'm talking here today. I've been there, and I can strongly discourage you from continuing being that person if you are such an infrastructure person in the team. It introduces a whole set of possible problems, like this one's. Bus factor, like the famous term, that that person can suddenly be hit by a bus, and well, that's it. No deliveries for two months. If you successfully avoided that bus, you can still find yourself unable to take that great vacation that you were planning for, because the team is depending on you to deliver some new configuration changes and so on, to release this new feature for that account launch, whatnot. So it's also a pressure on the team member that maintains the infrastructure. It slows down the team. That's kind of natural. You have like this obvious bottleneck in the team. If there is a lot of changes that you need to do, everything has to go through that person, and they would be just swamped with work. And it's a problem with scaling the team. You can split the team, but it's kind of hard to split the person while keeping them working. And it's not so hard to see how this ends up being a vicious circle. That's why this is a sustainable structure. It keeps the same. It keeps going to the same structure. It takes time to explain all the details of your infrastructure to your team members, to your peers, and it might be quite complex. And you don't have that time because we need to release this feature now. I don't like, sorry, I need to finish this. I can't have time to explain it. And it's way faster to implement those infrastructure features yourself in the short term because, well, I already know everything about it. If I pair with someone, they would be kind of slow to ramp up and so on. So this, as we can see, it ends up being some sort of a local optimum. So it gets worse before it gets better. It gets worse when you try to spend time on explaining the infrastructure to your team members. You will have to spend time on actively working on it, but it has to be done. You have to actively spread the knowledge about your infrastructure in your team to avoid all of those risks it introduces in your organization. And at some point, it will get easier. You'll have more time, and the organization will have less risks. And you will be able to take that great vacation. So some of the tools you can use for that are pair programming, kind of obviously. Team walkthrough, where you can just start maybe with introducing your team members to the tools that you are using, to that Packer, CloudFormation, whatnot things. Infrastructure chat, where your whole company discusses the issues about the common problems with the infrastructure. You should probably suggest your team members to join that chat and at least look at the issues people have to be in the loop. And such things as chat ops. Well, I maybe should clarify a bit. Such tools like WhoBot, it's a chatbot. They allow for basically learning how to work with infrastructure by watching other people work on the infrastructure through public channels. So you say, okay, give me that CPU utilization on that machine, and the chatbot displays it. Other people can see that you requested this and did that. We haven't actually used it just yet in the team, but we're very passionate about trying it out. So yeah, spread that knowledge about infrastructure. Don't be that single link. Okay, the last one I wanted to talk about today is structuring the microservices, some things that worked and didn't work for us. So I don't think I need to sell you the idea of microservices, well, at least not in this talk. Let's assume we're going for this architecture. The most interesting question is, how do you structure things? How do you split your system into a set of microservices? And it's kind of hard to come up with a single proper way to split your system. If you do that, you'll be okay. It's kind of easier to tell from the experience what didn't work for us specifically, for the teams that I've been part of. So these are some of the mistakes that we made along the way. And I just realized the word got split, but well, I hope you can understand what I meant. So the first of the mistakes was inappropriate structuring of services, inappropriate split, where we basically overdid microservices. Let's go for the microservices. Everything is a microservice. Great. So we ended up with this sort of structure. We have a single business function that is fulfilling a certain single need. And we have 3 services doing stuff for that business function. So actually, this ended up not that great because it introduces cross-cutting concerns. You need to modify all the 3 services whenever you have to change the business requirements for that specific business function. So what we ended up was this. But please don't interpret me incorrectly. I don't advocate for placing everything into your single service. It's rather, you should really think on separating that single business function and think, okay, does this belong to this function or not? So, and place everything related to it in that service. And if the service goes too big, maybe it's fine. Maybe it's okay. Another mistake, one of the first inter-service communication attempts via message queue was using protocol buffers, protobufs. And protobufs are great for performance and schema validation. Don't get me wrong, protobufs are amazing. But maybe it's not really the first thing that you should go with when you start your microservice architecture. Maybe you should take something simpler, because the additional code to work with protobufs made it harder, like added complexity, and the binary protocol over the wire was hard to debug as well. So we ended up going with JSON for now, but nobody says that we'll not go with protobufs in the future or Avro or whatnot. But start with something simple. And of course, like monolith always finds a way. And another thing that you just keep adding stuff to your existing services because it's the way of least resistance. And one day you wake up and it's like a huge pile of stuff. Yeah. And there are actually several opinions on whether you should start with the monoliths or you should start with the microservices. There's a whole discussion about it in the blogs. Martin Fowler actually posted you should start with the monoliths on his blog. And then he actually posted a guest post that you should start with the monolith from another guy also to his blog to kind of show that it depends. It depends. And like my opinion is that I don't lean towards any of those, but once you figure out your domain, and you should try to do this as soon as possible, you should be able to split the services into, like the system into a set of cohesive components. And it might be good to start splitting at least some things early, because it will force you to start thinking about such things as like deployment, config management for multiple services. Not when you have one service and you can hard code all the things, but yeah, start kind of modularizing it. One of the things that actually did work for us was separating the services based on the SLA level. This is a good way to reduce the risks in the overall system. Say, an asynchronous batch processing service will highly likely have a different time requirements for completing a transaction compared to a customer-facing one-time password generation service. So it is a natural way of splitting the services based on the risk. So yeah, it makes sense. All right, that's kind of it. I would like to do a short recap. So give continuous deployments a try. If you are still skeptical, I'd like to encourage you to experiment with it. Give it a try. If something goes wrong, you always have your current setup, if you are not already using continuous deployments, of course. Avoid silos. Spread the knowledge in your team. That's the dangerous part of the DevOps, that you have this possibility that one team member knows everything about a specific function, and if you lose them, that's it. And constantly think about your microservices architecture. Reevaluate, are we doing things right? And whether we should be splitting them out or merging them back, and so on. It might take some mental energy, but you have to do it. So that's it for me. Thank you.